If you participated in our recent series of webinars on data quality, you'll have heard us talk about something we've been working on called the EasyMorph Data Quality Toolkit. This is a series of files, a toolkit for you to start the process of defining data contracts and how to test or automate that testing of your data sets against those contracts to see if your data quality meets the requirements in the contract or not. Don't worry if you didn't see the webinar, there will be a card in the top right hand corner of this video, or alternatively a link in the description below this video. So let's look at how we can download the data contract toolkit and how we can start to implement it in our data sets to test our data quality. So to get started, head over to the easymorph.com website and to the EasyMorph community forum. If we search for data quality toolkit, you should find a post where we released the toolkit last week and provided some information about what the toolkit contains and how you can implement those tests and checks that the toolkit can currently handle. The toolkit's provided as a zip file. You can download this toolkit file, and as you can see, it contains a series of morph files and other files which make up the toolkit. The most important two files in this this toolkit are the data contract example Excel file. This is an example or a template for a simple data contract created in Excel. We chose Excel because Excel is familiar to everybody. You all likely have Excel installed on your computer, and if you don't, then you can use Google Docs if you have that instead, or even LibreOffice or OpenOffice, which both can open Excel files as well. The next most important file is the test data contract morph. This is an EasyMorph project, a very large and complex set of workflows, which you don't have to understand how it works. Simply, you take a data set, you create an Excel data contract, and then you call from your workflow the test data contract morph, passing it the data set and the path to the data contract file you've created, and the test data contract morph will then automate the process of testing that data set against the requirements in the data contract file and passing you back a set of results. So it's a bit like a black box. You don't have to understand how it works. It's very complex. There are lots and lots and lots of actions and complex workflows within it. But it is just that black box that you can call and know that if you pass it the data set and the contract that matches it, it should give you back a set of results to tell you, hopefully, all of your data passes, or if it doesn't, which records have failed the data contract tests and why. All of the other files in this zip file are sort of optional. They are just examples to show you how you can implement these tests in your workflows. We also provide a sample data set as well that contains some errors that we'll walk through and show that, and which the example data contract file is created to match that data set. And also the data contract toolkit, or the data quality toolkit, permits you creating your own custom checks for bespoke requirements that are specific to your business. And so we also include an example of how you can create one of those custom checks and how you can reference that custom check in the data contract, so that the test data contract black box will find that extra custom check in the data contract file, and again we'll automate the process of calling that for you to do that check, that custom check, and include that all in the set of results. So let's walk through this toolkit, how we can get started implementing it, and look at what it can do. So the first thing I will need to do is extract this zip file to somewhere on my computer where I can start to actually use these files. So let's begin by opening the example data contract. I will open it in LibreOffice just to show that you don't have to have Excel, but I'm sure most of you do. The example contract contains 3 sheets. the first sheet, the settings sheet, is used just as a generic, mostly as an overview to provide information about this data contract and what data set it is intended to be used for. The most important thing on here, however, is the version. So it's really important that you version your data contracts so that as the requirements change over time, as data sets change over time, it's obviously inevitable that you will have to tweak and change the data contract to meet those requirements. And without any sort of formal versioning, then it can be difficult to know that when you look at a set of results, which version of the data contract does that set of results meet? Has it failed because I'm still testing it against an older version, or is it failing the latest and greatest version and that's still a problem? So it's important to know that that version exists and to sort of use that in versioning your contracts, and the results that are passed back will contain this version number out of this contract file so that it's clear which version of the contract it was tested against. The next sheet, and the most important sheet of all, is the field sheet. This is where we define all of the fields which we expect to be in the data set, as well as all the information about those fields, what we expect them to contain, and these are sort of the settings for all of the individual tests which will be performed on that data once we're past the data set and the set of data contract settings to our data contract test morph. So we'll run through briefly this and look at what it's possible to include, or what you must include. The first column after the field name then is the primary key indicator. This is an indication as to which of these fields is the primary key, and this is important because in the results, as well as passing back the value of the field that failed the test or passed the test, it also will include the value in the primary key for that record, so that again, if it is a problem and there is an issue in the data record, rather than having to try and find that specific value in the source data or the source system, we can also look at what the primary key value is and search for that value and find that exact record in the source data set. You can only have one field in here listed as the primary key. If you have more than one, you will receive an error back when you try and test this data contract. So it's important that one field is listed as a Y, for it is the primary key field, and all of the others are N's. The next is the data type. This indicates what type of data we expect to be available. EasyMorph has various data types: text data, numeric data, Boolean values, and then two special types, error or empty. Currently, the data contract supports numbers, numeric data types, text data types. We also support some special versions of text and data types. Date number, this is where dates are stored in the data as numeric values, and because they're dates, we can not only test them numerically but also to perform date type testing on them as well. We also have the equivalent date text, where the date is stored as a text value. And we have the same for timestamps as well, timestamp numbers and timestamp text. We don't currently have any special type for Booleans, but we're looking to add that into the data contract testing in the future. The other value that's possible is any. If the field is listed as any, then we expect that the field is likely a mixture of data types, and so we don't apply any specific test. We expect any type of data to be valid in this field. The next column is the allow empty column. This indicates, again with a capital Y or capital N, if we allow the value in this field in the record to be empty or not. Again, this is reference to the data type of empty, sort of within EasyMorph's data typing system. Again, very similar, y or n for do we allow or do we expect all of the values to be unique. So if we expect all values in every record to be unique, then y in this column will test that and to return a pass or a fail if they're not unique. If we don't expect them to be unique, again, everything is passed for that check. Then beyond this, we get into the individual sort of testing and checking that can be dependent on the type of the data type that we define. So first, for numeric values or numeric data types, we have a series of tests that we can perform around what are our expected values in those fields. The first two being the minimum number or the maximum number we allow within that field. And so we will check every data value that is a number, and we'll check to see if it is between this minimum and maximum. If it's a number and no minimum and maximum is given, then the field will pass that minimum and maximum test, or it is not applied, not tested, because no values were given. You can also pass just one or the other. You don't have to have a min and a maximum. You can have just a maximum or just a minimum, and they can also be negative numbers as well if that is what you need or what you have in your data. The next column indicates that we expect the numeric values to be integers, and so we'll test all the values, and if they are integers we will pass. If they are not integers, then or they are decimal values and they are numeric, then they'll fail the test if there is a y in this column. Then we move on to text values, and again, text-based values can have a minimum or maximum length. So this can be anywhere between 1 and any sort of number that you require as your text length. And again, you don't have to have a minimum or a maximum. You can have one or the other value in here to test, and the test will check if that text length in the field is between that minimum or maximum value. Then we move on to the date tests, and these are applicable both to date number and date text. So we can specify a date as the minimum or the maximum, and again, EasyMorph will test if, or the data contract test will test if the value in the field is between those two values. There is a special value that is also possible, which is the all in capitals, the word today. This will be substituted in the test for today's date, and so that can be in the minimum or the maximum, and again allows you to test if dates are in the past or in the future as well. And then finally, if the value in the data is stored as a number, then we don't need to have this text date format, because these values are stored in the Excel as numeric dates. But if they're stored in the data as text dates, then we've specified the data text or the date text type, and we need to give an indication of the format of those text dates in the data. So this is important. It's not the format of the data or the dates specified in the contract. It's the format of the dates in the data, and then the check will take those values which are text, and obviously because it's text we can't easily check with whether they're between two numeric dates, so it will use this format to turn that text in the data set into a numeric date and then test it's between these two provided dates. With the next set of columns, or the next three columns, are exactly the same. They are for timestamps, and so again I can create minimum or maximum timestamp ranges for that data to be tested against. And we also have a keyword like today, but for timestamps it is now, and if that now keyword exists, it will be replaced with the timestamp at the point when the data test morph is run. And we will test again if they're between the minimum and maximum timestamps. And as before, we don't have to have both. We can have one or the other, or even none of them if we don't wish to test a range. The next column is the possible values column, and this is generally applied to text-based or even any fields. And this allows us to test that the values in the column are only those within a specific list that we want to test. So I have a state field, a US state in my data set that we'll look at in a minute. And so I have a list of all the data or the states that we expect in that data. And again, it will test that data to see if the value is in this list. The list is pipe separated list, and so that is in just a long string in here of all the values for the states we expect to find. Alternatively, another example is the data can have yes or no in another field, and so I've got a list defined here of only yes or no. And so if any string or any value exists in that field that isn't in this list, either the US states or the yes or no, then it will fail the test. It can be a bit of a long list of values that you might have, and so this is can be a very long string. Check out the community post on the forum. People have already sort of provided examples of how they've made this field calculated in this Excel file so that they can manage a long list somewhere else or in another sheet in this Excel file to be able to manage that list a bit simpler and then automatically calculate this long string in Excel. Moving on, we next have the regex format. And so if we specify in here a regular expression for the format that we expect the values to be in our data, that EasyMorph will test those values to see if they match the data format that's defined in the regular expression. These can be a little bit complex to understand. If you're not familiar with regular expressions, they can be a bit difficult to understand. Don't worry, in a minute we'll take a look at how we can help to define those regular expressions so that you can put them into this data contract to test. And then finally, the following three and the last three columns are for defining custom checks which are performed in our data contract checks. So we have all of these standard tests that are defined in the data contract and which the data contract testing morph will test for, but often there are examples where there are some check you need to perform that's unique to your specific set of data. An example might again be the format of a specific field, which is quite complex, and so maybe it's difficult to do in a regular expression. Or it may be that there's quite complex logic around the testing of the value in this field, and so it's dependent on other fields. And so this last three fields let us specify both the path to another morph file that can do a custom check. We can also pass settings, which is passed as a parameter to that morph file, and that can just be a simple value, or in this example I've created a very simple JSON to be passed so that more than one setting can be passed to that custom morph. And also the names of any other fields that we need to be passed to that morph to perform that check. So I may need a certain value in this field, and that value can be dependent upon what's defined in these other fields as well. Maybe it has to be specified if these other values are specified, but it can be empty if not. Those kind of custom checks could be really complex, and so we have obviously no way of standardizing what they might be other than a regular expression format check, and so you would need to create a custom morph to check that unique sort of requirement within your data set. So let's move on and let's look at how we can start to implement this data contract and checking our data set for it. So let's head back to the files we extracted from the zip file, and let's open our example data test so that we can see how we can then use that data contract that we've defined and you create a couple of very simple actions in any EasyMorph workflow to test the data against one of those contract files that we've created. So let's open EasyMorph, and take a look at this example. So it's a very simple example. It, in theory, could be even simpler if you wanted it to be, but this shows you just one example of how to take a data set, test it using the data contract testing morph, and to then get back that set of results. And in here, optionally, look at how we could stop that set of data progressing further down the chain of data, propagating into any other business dashboard or tool that we would not want data or erroneous data to be passed into. So the first action is to load in that example dataset file that we saw in the toolkit. So we have the example dataset file in here. If you are familiar with EasyMorph, then you will have no doubt at some point looked at the Inc 5000 demo or example file that comes with EasyMorph desktop when you install it, and it's just a copy of that data with a number of problems and data quality issues in it, so that we can see those data quality issues being tested for and what results come out as a result of that test. The most important action then to add into this morph to be able to perform that test is to call our test data contract morph file. So this is the very complex file. Again, it's in that toolkit that we unzipped. It's this last file, test data contract.morph, and that's that black box that performs all of the tests, and we don't have to worry too much about exactly how it works or what it contains. Just know that it will perform a test of that data against that data contract. So the call action calls that EasyMorph workflow, that .morph file. We ask it to return a set of data from it, and you can leave it as the default. There are lots and lots of tables in that morph. Don't worry about what each one of them does. You can leave it as default, and you will get back the correct set of results from that morph. And then we must also pass in a parameter to that workflow when it's called, which is the data contract file that we want to test the data set against. So there are two variables or two parameters in that data contract test morph. The contract file, which is the path and the file to our Excel file that we've specified our data contract in, and an optional parameter which we don't have to pass, and this indicates whether we should output the results back to the contract, that other sheet. So when we looked at the data contract Excel file, there is a third sheet. It's empty in the example you get, but if we put a Y into this parameter, then the test will not only return the results back to the EasyMorph workflow we called them from, but it will also save those results back into that results sheet on the in the EasyMorph data contract that we've created in Excel. I won't bother with that. I will just leave it configured as is. So if you add a call action into any EasyMorph workflow, configured to pass to this, to call this test data contract morph that you downloaded in that toolkit, requesting the result, the default table back, and passing it also in the parameter contract file, the path to the Excel that you've defined for your data contract. When that action is run, it will perform a bunch of tests in that data file. We will get a pop-up which is a warning. It successfully ran, but there were warnings in that contract file. You don't have to worry about those warnings. Those warnings are telling you that it found some errors in the process, and so was not, it's not a clean, perfect run. There are some errors in that data. Again, if you're automating this, if you've implemented this in one of your existing ETL or data processing workflows, and you've scheduled that, or you've got that triggered to run on EasyMorph server, then it will automatically, skip over this warning because it has successfully ran. It's just noting that errors have been found. And we can see that we got back a set of results from that call to the data contract test morph and it testing against that data contract file. So let's take a look at what the results show. First of all, it tells us the file, the full path to the file that held the data contract, that it was passed and which it performed the tests against. The next is that version number. That's the version of the data contract from that first setting sheet in our data contract. We had that version in there, and again that just helps to know exactly which version of the data contract we performed the test against. We then have an indication of the column, which column was this test performed on in the data file or the data set, what the value was in that set, if it's relevant to this test, if that is other than the primary key, what primary key field value was that test record against, and also then what check was performed and what the result was. Now these first ones are checking if all of the fields in the data set are in my data contract, and some of them are not in that example contract. So obviously in that instance it's about the field, and so it's not a specific value that we're performing a test against. So the value and the primary key are both blank for this test results. But again, we can see is the field, the test that was performed is the field in the contract, and whether it passed or failed. And if it failed, we get a true EasyMorph error. So again, EasyMorph has a data type of error, specific and unique to EasyMorph, and then we can see that those errors are occurring when, in this instance, the field in the data set is not found in the contract. Or alternatively, we do have one that's in the contract which is not in the data table, and again we get a slightly different error for that. If we scroll down a bit further, we can then start to see all the individual checks that are starting to be performed as we specified in our data contract. So the first test is to find out whether it has the correct data type or not. So again, we in this instance find out, are there any values in our ID column where the value is not the correct specified data type, which we can see this text value that exists is not numeric, and we specified in our data contract for our ID field that we expect them to all be slightly further, we expect them to all be numeric values. So there are a long list here. There are far more passes than failures, which is a good thing, but we have, as we scroll down, we can see there are other failures and exist. So again, here we have a date range, and so we have dates in our that are stored numeric in our data which are outside of the range that we specified in our data contract file. We also have timestamps outside of the ranges we specified. There's all sorts of different errors in here, but there are a lot of passes. So the other thing we can do is add in a filter by type action immediately afterwards, and the filter by type is filtering based upon the data type in EasyMorph, and as we said, there is a specific data type in EasyMorph for errors, and so I've filtered on just those errors, and this lets me then just see all of the errors only. What are those errors and how are they appearing in the data? And I could output these errors to a file and send them to somebody to ask them to go and correct them in the source data system. I could pass them into an EasyMorph server board as an issue and create an issue for each one of the data errors that occur, and I will then be able to assign those to people and get them actioned that way. But ultimately, I now know all of the values in my data set, what passes and what fails those data checks that I've specified in my contract, and I can decide what I'm going to do about them. I could output these somewhere, as I said, for somebody to action, but one important thing I might also want to do is prevent those values from being pushed, or this whole data set from being pushed downstream that ends up in a BI reporting system or a report of some form, so that users aren't then reporting or seeing reports which are on incorrect or invalid or incomplete sets of data. So in this example, again, I've included a skip on condition in another table action. So I'm inheriting the data set, a derived table from the same data set, but in this instance I'm skipping the rest of the actions, which is to output this data set to another file where the table, the test data table, has any errors in it or not. So again, I don't want this data to be pushed downstream. I output into a different file that might then be used in a report if I got any errors back in testing that data set. So hopefully from this you can see how you can very easily, with just one action, define that data contract in Excel and then add this one call action to call that data contract test, or that test data contract.morph file, passing it the data set from my workflow, and getting back a set of results, testing it against the data contract that I specified. What we'll do is that we'll lastly look at how we can then implement custom data checks in order to our data contract as well, so that we can start to see how not only can we use those default inbuilt checks, but how we can also do some customization on those checks to find things that are unique, specific to my business. So let's first look at those regular expression checks. So these allow us to define a regular expression. It looks gobbledygook, a lot of sort of nonsense if you're not familiar with regular expressions. But what regular expressions allow us to do is define a format, and then we can test that format to see if the string of text in the field meets the requirements of this format or not. In my data set that we were looking at in this example, I have a column which has a company code field in it, and these codes should be of a specific format. Always, they are 2 letters followed by 5 numbers, and then either an X or a Y on the end. And I want to be able to test all of the values in this field to make sure they meet that requirement or that format. And so I need to create, or I can create, a regular expression check which checks that we do indeed have the right values that meet that requirement of 2 letters, 5 numbers, and an X or Y. And anything that it doesn't match that pattern would be a failure in that check. So in order to do that, we have to be able to create this regular expression in define it, and that can be a little bit difficult just to type and write and understand. So I would highly recommend using one of the many tools you'll find online for helping to build regular expressions for you. This is called regex101.com. It's my favorite, but there are others available and you can explore and find them. One thing to note is that regular expressions come in different flavors that are slightly different, and so what is possible in some is slightly different to the other, or the syntax can be slightly different. So it's important to note that before you proceed that you are using the .NET version of regex, so that we ensure that what you create as a regular expression matches what you want and what EasyMorph will use to perform that test. I can then start to build up my regular expression to define the output of what we need, that format of what we need to be. One thing to note is that if I don't define the start and end of my regular expression, then EasyMorph would match the definition, the format, at any location in the text, in the data. So if I did indeed have a value that met the correct format of 2 letters, 5 numbers, and an X and Y, but it had more text before or after, it would still pass the test if I didn't include the starting indicator that tells me I need to start the string here. And I can see that that is a hat symbol for me to start. So I can insert a hat into my expression to indicate that it must start at the start of the string. And equally, we can use a dollar symbol to indicate that it has to be the end of the string and there's no other text after it. And then between these two, I can define the definition of what we need to have. Now, I would like there to be 2 characters which are that are only alphanumerical characters, A to Z, and they must be uppercase. And so again, I could define a range here of using square brackets of capital A to capital Z, and I actually need specifically 2 of them. And so again, if I scroll down, I can see that I can define exactly 3, or in our instance 2 of those characters. So again, the preceding block, either A to Z, I need exactly 2 of those characters. We then need 5 numeric characters in order to get back those 5 numbers. And there is a shortcut word. I don't have to put open bracket or open square bracket 0 to 9. I can do /d to say it has to be a digit, a numeric character. So we want /d. And again, we want exactly 5 of them. So in squiggly brackets, we can actually have exactly 5. And then finally, we said we need either X or Y. And we can see in the top example that again, in those square brackets, if instead of A to Z, if we just put Y or Z, it will match one of those characters. And then we've defined our regular expression. This is the regular expression that we then have inserted here into our example data contract, and that is what EasyMorph will test against to see, do the values match that format. And there's very, very complex capabilities in regex to have this format or that format. So there's lots of things you can do to build up quite complex regular expressions in your tests in these example contracts, to be able to test the values in them to make sure they meet the right format that you want. And lastly, then let's look at how we can create a custom EasyMorph workflow to perform a custom test. And in this example, we're going to do exactly the same test in our just using a custom check instead, but you could create a custom morph file, a custom workflow based upon this example to perform any test you want or need in your data, so that you can match exactly the requirements of your data. We couldn't possibly build all of the possibilities into this, and so this lets you extend the capabilities of this default toolkit to perform some unique test that's unique and specific to your business. So again, in the toolkit, we have an example morph of a custom check. And if we open that into EasyMorph, we can start to see what is in this example check and how we can perform a test and pass back the set of results, so that we can get those results back into our full set of results with all of the standard tests. And so we have one set of results for all the checks, including any custom ones we've created. So this any custom morphs that you create have to start with an input action. so that they can receive the set of data being passed from that custom EasyMorph or that call to the custom EasyMorph. So because I've specified the path to a custom check, then that I don't have to add any more call actions to my workflow. They will automatically be called by the custom check morph or the check morph that does the calling. So this test data contract, we call that from our main workflow, and it will handle calling the example custom check morph because it finds it listed in this contract. The next thing to note is, as well as that input action to receive that set of data to perform the test, it also has to have a parameter called settings. Into this parameter will be passed any settings that are also defined in our data contract file. So again, we had this custom rule settings column. In it, we have some JSON in this example, but it could just be some text, or you could have a pipe separated list again, or anything you want, you could pass into this or put into this column, and it will be passed into that settings parameter that your custom check morph must have. And those are the main two requirements. That's all you must have in this morph. And it's important to note that every other action in here is performing the tests that I need it to perform and passing back the results that I want to pass back in the same format, so that those results can be added into the list and matched with all the other results. Because I'm passing some JSON in the parameter field, then I first of all have a calculate new columns action to bring that parameter in and put it against each record in my data set as a settings parameter. I then am using a JSON or extract JSON properties to take that JSON that is in that pass parameter and therefore in the field settings.json, and to split it up into two fields, a letters field and a numbers field, so that I can use those in my expression. And then I create a calculated column. I've called my column quality check results, so that the result goes back into the same column in the full set of results that are passed back. And then I can create any expression I want in here to perform that test. So as a first example, I have a check which checks the format of that company code to see if it indeed has in it what I need with regards to the format. So it checks the length is the correct length. It checks whether the left two characters, the first two characters, are indeed alpha characters, A to Z and in capitals. It then checks whether the next 5 characters are indeed numeric number characters, and then it checks if the last one is X and Y. So it's doing exactly the same job in this default format as that regular expression is. And if it passes that check, it replies with the text pass in capital letters, again to match that what you get in the standard tests. And if not, then it creates an EasyMorph error using the error function. And again, you can pass any text you like back to indicate what that error is. So in this example, it does not pass, it does not contain a valid company code in the format that we've specified. We do have a commented out an additional example at the top, which can look to perform another check. So this morph can perform more than one check. So if I go back to my data contract example, I included in here in the final column some indication as to additional fields that are in the data set that I need to be able to perform the custom check. So as well as the column company underscore code being passed to that custom morph, it will also pass these two columns, rank and company, from the data set. You don't have to pass any more columns into there. You can pass one or as many as you need in a pipe separated list. It doesn't have to be 2. And as an example then, they must be populated before I perform the custom check. So again, if I go back to my EasyMorph workflow custom check, at the top in the commented out example, it again is checking whether the length of the values in the company and the rank field are greater than 1. They have an actual company in there, and if not, then we get an error code saying the company or the rank are missing instead. And then finally, within our example custom check, we are then removing all of the columns that were sort of were generated as part of creating that set of settings and splitting out the JSON, because we don't need those into the contract check, or we don't want them. You could pass them back. Again, it will just mean that you get extra columns in the result table which show what that set of fields that were created in that custom check, and you might want that so you can see the values that were used in the check, or you might want to remove them in here. So as I said, you can create your own custom checks. I would recommend taking this example and modifying it to perform your check, because it will help to make sure that you have the input, that you've got a parameter field set up to as well to receive any settings from that morph, or from that data contract file, should I say, and then you can modify this to create those results. And as I said, that EasyMorph black box that performs all of those checks, I don't have to include an additional call action. It will call, by calling the test data contract.morph file, it will find those additional custom checks specified in that data contract Excel file, and it will handle calling those for you and getting any extra results and passing them back. So we can actually see that that's happening in here. In here we can see that the custom morph, or the company code, if we filter, we check the custom check that was using the example custom check morph, we can see all of the results that come back. We do indeed get 2,471 which pass, but we get 44 which don't, and they fail, and we can see that those errors are being performed in that one single call, just because that was listed in the data contract file, and we can get back that there are errors where the company code doesn't meet the format because we've used that custom morph. So as a quick recap, let's look at how we can add a test using the data contract and the EasyMorph data quality toolkit to test another data set in an EasyMorph workflow, and how we can add that from scratch. So I'm going to pick the community users example. This example ships with EasyMorph desktop, and it goes and fetches some information from the EasyMorph community forum website about the last time people were active. And so I want to place the test at the end to make sure I've got all the data back and all that data is valid. And so as you can see, my data set has 3 fields: last seen, which is in fact displayed as a date, but is actually a timestamp. We can see that from the decimal value, and then the name and the username of the person that was last active at that point. So I've created a copy of my data contract. This data contract then allows me to test those fields, so I need to set it up correctly. As you can see, I've changed the version and the description on the first settings sheet. On the field sheet, I have added those 3 fields and set them up as I think they should look, and the data should be populated. My username is my primary key. That's the unique value within this data set. As I said, that first column, the last seen at, is a timestamp stored as a number. So I've entered timestamp number, and the name and the username as text. I expect all the values to be populated, so I don't allow any values to be empty. And I've also specified that I expect my username field to be unique in there. I don't expect any repetitions because it's my primary key. And then a little further across, under that timestamp, I've defined a minimum and maximum. So I don't expect data before the beginning of 2020, and this is historic data, when were people last active, and so I don't expect timestamps in the future. So I've included that keyword now so that this always is replaced with the current timestamp as of when the test is performed. So I can save my data contract file. I can then look to close that, and we will add and modify this workflow just to add in that call action. So I shall add the call, another module or project action at the end, immediately after that dataset. By example, or by default, should I say, it always picks module as what it's going to call, and that's to call another module in this workflow. We want to call a different EasyMorph project, and we need to select the test data contract.morph in that data quality toolkit that you downloaded. We wish it to return the results so that we can see them, and we should leave that as the default data set. And then we need to tell it where that contract file is that we created. So we created the data contract community users example, or data contract file, and I won't set the parameter for passing back the results into the data contract file. Let's simply apply that, and EasyMorph will run that action for us. And as we can see, it's performed all of those tests for us on that data contract file, and we can see the results. So as we did in our other example, let's add a filter by type action so that we can just see if we got any errors. So we'll keep only errors and apply. And as we can see, it passed everything apart from 3 values in the name field are missing, they're empty, and therefore we've failed the check for empty values. So hopefully that's given you some insight in how you can get started using the EasyMorph Data Quality Toolkit, how you can define simple data contracts, what you're expecting data sets to look like, and how you can automate the testing by simply adding one action into your existing EasyMorph workflows to test a set of data against a contract and receive back an indication of the data quality and all of those records that may not meet the requirements. If you have any questions, head on over to the EasyMorph community and either add your question to the existing Data Quality Toolkit post or raise another post. And also, if you have ideas for how we could improve the Data Quality Toolkit, additional tests that maybe we could create, or if you'd like to share custom check EasyMorph workflows that you've created that you think others might benefit from, then we'd love to hear about those ideas and see what you guys have been doing and how you've been solving your data quality problems using EasyMorph.